This is Bitnar Talks, the engineer takes on construction. Episode 12. Hi, I'm Piotr Bitnar. Each day I help my clients plan and design building projects through Bitnar Limited, a consulting chartered structural engineer's practice. My biggest passion and the cornerstone on which I've built my business is finding clever solutions for construction projects. I am a chartered structural engineer and a budding software developer, so you can rest assured that I will strive to talk about the best practices and the use of new technologies in the industry. And if you're embarking on a construction project or are involved in planning, designing and building the world around us, you'll find this podcast useful. Approved Documents Structure, Part 1. Hi there, and welcome back to the Bitnar Talks, your favorite podcast on all matters of architecture, engineering, and construction. It is Thursday, the 11th of August 2024, and I'm here back with you with the 12th episode and further information on approved documents. It has been a busy week. We helped people achieve their planning permissions and full plan approvals for building control, and visited some dangerous structures to assess on their conditions. I shot some pigeon clays as part of the local Kent networking group, closed new clients, and managed to do it all while preparing this podcast for you. What would my childhood hero say? Who does not love it when the plan comes well together? Last week, in the episode 11, I took you on the journey through all approved documents and how it all comes together. There are 18 requirements with 17 approved documents, as requirement N hides within approved document K, and there is an additional document that deals with materials and workmanship. I will now move us to more detail within the first requirement, structure. Alright, let us unpack it all a bit. So without further ado, let's dive into the structural requirements of the approved document. The purpose of this material is to give you a general appreciation of the requirements put on you by approved documents. The approved documents form the primary source of the information prepared by the Secretary of State describing how the building regulations requirements can be discharged. These form guidance for registered building control approvers to discharge their duties, so the first thing they will do will be to take your project and dissect it point by point, ticking all the necessary boxes identified within the document. In this episode, I will talk about the first consideration within the schedule of requirements identified in the Building Regulations 2010, which is structure. There are three considerations brought up by the regulator, which is A1 loading, A2 ground movement, and A3 disproportionate collapse. In the main part of this episode, I will talk about the first two aspects, loading and ground movement, and I will leave the disproportionate collapse for its own episode which will form part 2 of the approved documents structure. I will begin by telling you how the document is structured, and we'll go section by section giving you simple reasons behind the text and my commentary. Alright, let's get on to it. So the approved document A is put in place to give practical approach to the meaning of the building regulation requirement A. I will read it for you now so you can appreciate how broad it is. So the regulation says, loading, A1, paragraph 1. The building shall be constructed so that the combined dead, imposed and wind loads are sustained and transmitted by it to the ground. Subparagraph A, safely, and B, without causing such deflection or deformation of any part of the building or such movement of the ground as will impair the stability of any part of another building. Paragraph 2. In assessing whether a building complies with subparagraph 1, regard shall be had to the imposed and wind loads to which it is likely to be subjected in the ordinary course of its use, for the purpose for which it is intended. And aspect 2, ground movement. A2. The building shall be constructed so that ground movement caused by A. Swelling, shrinkage, or freezing of the subsoil, or, subparagraph B, landslip or subsidence, or then subsidence arising from shrinkage, in so far as the risk can be reasonably foreseen, will not impair the stability of any part of the building. So here you have it. You can appreciate this is quite general and close to impossible to make the same sense with anyone else than with yourself. What I mean by that, I may have a different approach to yours and you may have different approach to mine. To me, a requirement regarding loading is simple. The structure must be safe on its own, itself, for ordinary circumstances and cannot unduly impact any other structure. And the requirement regarding ground movement simply states the building needs to be placed on sound enough ground so any movement will not impair that building's stability. Simples. So as long as the building is safe and stable and does not impact the neighboring buildings, it is fine to the letter of the law. But what does that mean exactly? No one knows and no one assigns their judgment to it. At least the regulator does not, as however detailed and prescriptive the approved documents may appear, they begin with the information that there is no obligation to adopt them if we want to discharge the requirements in other way, nor the regulator or registered building control approver will be liable for the use or insistence of any particular solution from that document. Unfortunately, the approvers have the power of veto, and the only way they can judge on the proposal is often approved documents only, so the principal designer will be in most cases restrained to the use of these documents. So let us see what is this document about. The approved document approaches the requirement of structural safety by listing the possible documents that are also approved and applicable, and the latest revision of these documents should always be taken into consideration. And that is section 1. It allows us, chartered structural engineers, to use this information, use the years of knowledge and experience to create to specify any needed project out there. Starting from small projects like described in this approved document, going through hospitals, offices, multi-use, high-rise, tunnels and bridges. Just to name a few. Then the approved document goes on to giving directions for sizing of elements in traditional buildings to carry load and wind in section 2. Section 3 deals with wall cladding, and section 4 deals with roof covering. All these sections address requirement 1 and 2 of the regulations. As mentioned before, requirement 3, the disproportionate collapse of buildings, will be talked about in the next episode, as I think it requires its due consideration and more attention. There are 23 diagrams and 10 tables that accompany the text of this document and assist you in understanding and discharging the requirements. It should be noted that the old British standards are no longer approved, were substituted by Eurocode alternative, but in practice I have not seen an officer who would not approve old standards if these are presented to them. I've received documentation that bases its design on standards going back half a century, and these were approved. I'm interested if this will change now with the onset of Building Safety Act and the requirement of competence. Anyhow, the list of approved standards can be found in the document, and it is prudent to refer to these standards as forming argumentation for your design decisions. The list contained within section 1 concerns ways to approach structural analysis and design and typical loadings and actions that this may be subject to, and all typical and codified design circumstances covered by Eurocodes, their national annexes, and supplementary documents covering their use and interpretation for general applications. This section also references documentation requirements posed by localized ground movement, things like landslip, mining instability, and field ground, as well as the approach to the appraisal of the existing buildings for their material change of use. Going into section 2, we are divided further into aspects A, B, C, D, and E. It should be noted that requirement A tells what to look into when considering aspect B and C, but in general, all aspects B to E can be treated independently of one another. So section 2A 1 states that the requirements of this document, this approved document, is concerning low-rise residential buildings only and should be read with paragraph B and C. Traditionally in Britain, buildings are made of masonry walls, be it solid or cavity, and timber floors, roofs. Engineered products are now also widely available. Subparagraph A2 limits the overall size and proportion of the building and gives restriction on layouts and cell sizes requiring walls to connect to each other either by bonding or by means of mechanical fixings, and requires roofs and floors to provide lateral support capable in transferring load to buttressing elements of the building. So when you think about the floor or roof, do not think about it in its traditional function of either carrying you and your gear in terms of floor or carrying roof tiles and snow, but also take in consideration that these planes, these floors and roofs need to connect to walls in both directions to stabilize the walls. The walls otherwise wouldn't be that stable and could collapse. Aspect B deals with timber. It directs us to trada tables, as the span tables have been removed at one of the revisions of approved documents some years ago, although engineer can easily calculate the required size and strength also. It also directs us to the necessity of treating timber when that can be susceptible to the presence of household longhorn beetle, which is usually southeast in our country, as it's dry and sunny. And dry and sunny areas are the areas that can experience longhorn beetles. Larvae of these little creatures simply thrive on dry sapwood of coniferous trees, on dry sapwood of softwood trees. Moving on to aspect C, which is masonry. The approved documents follows the approach here. The approved documents approach here is very broad, and departures are possible when proved by calculation or experience. The limit of application of this guidance is considered to be for the buildings of the height not extending more than 50 meters and no more than 3 stories, but also applies to small single-story non-residential buildings like annexes, garages, and outbuildings. The limit on the height may be more stringent, though, depending on the location and wind exposure of the building and the orography of the area. The proportion of the least width to the height cannot be more than 2, according to the document, so the smallest side of the building will determine the maximum height of that building, and similarly with annexes, if the annex protrusion away from the main building is more than 2 times its width, the height of this annex cannot be more than 2 times the smaller width. This is in place to make sure the building is stocky, or in other words, to make it possible for floors and roofs to translate the wind loads to buttressing elements. This is also evident in the limit of the floors, which area given at 70 meters squared for floors enclosed by walls from all sides, and 36 meters squared for floors with one side open. You will also note that walls are limited to 12-meter runs or 12-meter height between supporting elements, and that are its limits on the loads that are taken in consideration. So if you are intending to use the space with more onerous expectations, some localized strengthening will be required. Similar limits are put on the actual selection of the material for the wall and its thickness, which should not be less than 1 divided by 16. And if the wall is made of uncoarse rubble, it should be 1 divided by 12. So however high the wall is, divided by 16 or 12, and you have the thickness that you can use. There are further requirements, diagrams and tables that can guide you in selection of appropriate material, thickness, size and layout of your building, as well as number and position of wall ties if you choose cavity wall for your project. The rules of materials and its strength selection for different size of buildings and different position of walls is also provided. The specification for mortar too. This does take in consideration the safety of the building, but not its performance, so it may be prudent to use other strengths in your building to perhaps mitigate on the appearance of cracks or allow for future extension. There is a limit on the span of floors at 6 meters from the center of the bearing to the center of the bearing, which basically gives you around 5.9 meters between the faces of the walls. Which, guess what, if combined with the limit on the wall length, give us the maximum area for the compartment at 70 meters squared. Similar proportion to that of the parapet wall is given to the retaining power of the wall for retention of soil no more than 1 meter high, but it needs to be noted that the wall needs to extend for the entire story to provide enough load to resist pushing action of that soil. There is also a limit to the load at the foundation of 7 tons per meter. Run. You will find rules on buttressing walls, piers and chimneys, openings in walls, chases and recesses. Unfortunately, masonry is weak in bending, so removal of parts of panels or buttressing weakens the wall and may lead to the circumstance where the wall is weaker than the window or door you put into it, and the actual door or window will strengthen the wall, which by the way is not the reasonable ideal thing to do. As mentioned previously, the walls and roof needs to provide lateral support on all sides to the walls and generally be mechanically fixed to the walls. Whether it is your external wall, gable wall or internal wall, you need to make sure they are tying the walls together at least every 2 meter centers. However, some relaxation of these requirements are possible if there is enough contact between the wall and the floor and the building is no more than 2 stories high. You should also remember to strap the roof down to the wall at eaves at similar distances to avoid the roof lifting up. If the roof is of sufficient pitch and weight, this requirement may be omitted. It is good to voice the fact that if there are wall or floor openings interrupting the lateral or vertical restraint, there should be provisions in place to address this fact and enough restraint provided in suitable locations. The mentioned rules are relaxed a little bit when it comes to small non-residential buildings. It is good to note that this should be at least 130 kilograms per meter square of wall build-up if the outbuilding, annex or garage is smaller than 10 meters squared. It doesn't have to be, but anything over that floor area should have enough mass not to behave like a kite. It shouldn't be bigger than 36 meters squared with a maximum wall size of 9 meters and of 3 to 4.5 meters maximum height. 3 meters for the flat roof, 4.5 meters for the pitched roof. Walls should be tied to the roof horizontally and vertically, and piers should be provided wherever needed. Off to aspect D, masonry chimneys. Similar to parapet walls, these are referenced to be not higher than 4.5 times the smaller dimension if constructed in traditional masonry of at least 1.5 ton per meter cubed density. This provision is in place to account for the gravity load resistant overturning action of the wind. So here we have it. You need to have that mass so the chimney stack does not collapse. When it comes down to mass concrete foundations, when the mass concrete foundations are concerned, They are concerned with ground that needs to be uniform to mitigate differential settlement and damage that can reveal itself as the building settles unevenly. The mass concrete foundation strip should not be less deep than 150 millimeter, so should be at least 150 millimeter thick, and of 10 newtons per millimeter squared strength, which relates to Gen 1 concrete, but designation needs to take in consideration durability too. So very often in clayish or British conditions, really, you need to account for sulfates in the ground, so the foundation will very often be F&D designation. Some more expectations to width, formation depth and stepping of the footing is noted within the document. The foundation width generally requires no higher ground pressure than 100 kN per meter squared in granular soil and 50 to 75 kN per meter squared in cohesive soil. The requirement for the foundation is usually governed by the projection requirements rather than that of the bearing pressure. It is generally considered normal for the building to settle 25 mm during construction or in some time after the completion, which may be longer than 10 years. All building officers these days will ask you to identify trees nearby. We are receiving requests for up to 30 meters radius despite the type of the soil. This is due to the NHBC guidance. NHBC stands for the National House Building Council, who in their guidance documents, point 4.2, building near trees, go in depth in their expectations. It basically boils down to two solutions. If you build near trees, in soil that is influenced by the variance of water, you will either need to follow the NHBC guidance or have the foundations engineered. From my personal experience, I see how damaging to the planet this approach is. People pour tons of concrete in the ground and use polystyrene to mitigate impact on sites where there are trees within the limits of the guidance, but their influence does not extend to the perimeter of the site, rendering the guidance harmful. This can be very often observed by assessing the existing buildings around those trees and in even closer proximity to those trees. It is quite damaging for the planet. It's quite damaging for the pockets of clients, of people who want to build buildings, but maybe not for the contractors and compressive material producers, and certainly not for NHBC warranty provider. In general, we are used to specify the depth of foundation from around half a meter deep, 45 centimeter deep below the ground level, down to 1 meter. But following NHBC guidance, this may well go to 2.5 meter down, or will require a raft or piled and beam foundation. Off to section 3, which treats about wall cladding that needs to be structurally sound so it does not detach and harm anyone else. It also needs to be durable, resistant to weather, fire and passage of sound. But hey, one thing at a time. The cladding design and design of its fixing needs to account for all the loads applied at it and the behavior, thermal and moisture related. Fixings should be at least as durable as the cladding itself and be designed, developed and tested either by the specifier of the bespoke solution or manufacturer of the off-the-shelf solution. And finally, section 4, which similarly to section 3, in this time deals with roof covering, which needs to do a good job and neither fly away during inclemental weather nor to collapse when accessed by repair personnel. Some concessions are allowed here for areas not accessed by maintenance, like roof lights, but that's done. It can also be dangerous to increase the weight of the existing roof by more than 15%, which often happens with changing the attic space, adding insulation and ceiling boarding, or perhaps installing photovoltaic panels on the top of the roof, in which case engineering assessment will be required if that increase of weight is more than 15% of the existing weight. Contrary to adding weight to making the roof overloaded, removing the original weight from the roof can lead to the roof lifting off for a journey to a neighbor's garden. So to avoid such a predicament, it may be needed to strap that roof down to the walls. Okay, now let's summarize that a little bit, shall we? So yeah, the approved document A provides guidance on ensuring the structural safety and stability of the building and its compliance with building regulations requirement A. It covers aspects such as loading, ground movement, stability of different building elements, with emphasis on traditional construction considerations are also given for materials like timber and masonry. The document emphasizes the importance of ensuring that building can withstand various loads, including dead, imposed, and wind loads, without compromising safety or stability of that building or buildings nearby. It also addresses ground movement caused by factors like soil swelling, shrinkage, or subsidence to prevent any adverse effects on the building stability, or more likely the adverse effects on the insurance claims against NHBC. Different sections of the document focus on specific aspects of construction such as stability, timber elements, masonry, chimneys and foundations. For instance, it provides guidance on selecting suitable materials and ensuring proper connections between walls, roofs and floors. Requirements for wall cladding and roof coverage are also mentioned, highlighting the needs for structural integrity, durability, and resistance to external forces. Fixings for claddings and roofing materials must be appropriately designed to withstand applied loads and environmental conditions. Additionally, the document addresses considerations for existing buildings undergoing a material change of use and provides guidance on addressing disproportionate collapse, about which the whole part 2 will be treating next week. So here you have it. Approved Document A serves as a comprehensive resource for architects, engineers and builders to ensure that buildings meet regulatory standards for safety and stability for small and traditional buildings. However, structural engineers can go on and design much more using other approved standards and guidances. This is the end. I'm glad you stayed all the way till now. I hope this episode brought to you the expectations of the approved document A and that you now know how to use that document. If you have any questions, reach out to me on LinkedIn or send me an email. I'm more than happy to help you out. You can book an non-obligatory consultation on our website www.bitnar.co.uk and ask a specific question. Whether your question is if we can help you with your project or what should I do, we will be able to show you the right direction. At Bitnar, we help our clients design and execute their dream homes or investments. I will now take some in-depth look into the disproportionate collapse of buildings requirement to deliver some simple answers to you next week. For now, have a great weekend and successful week ahead. Thank you again for listening. Please voice up your opinions. I'm waiting for you on LinkedIn and I want to hear from you. Toodaloo!